Hello everyone and welcome to another Lancaster Safety Webinar Wednesday. If this is your first time joining us, welcome. We hold these free webinars once a month and invite everyone to attend. Our clients have the added bonus of having instant access to all of our safety and health webinars, newsletters, checklists, toolbox talks, training guides, and more. We're a full-service OSHA management company who truly believes in taking beyond the OSHA standards. My name is Rick and I am a safety consultant here at Lancaster Safety. I'm here today with Scott, one of our environment, safety, and health consultants and trainers.
Hi, folks.
Scott has been with LSCI since we started in 2004 and has over 30 years of total experience. With that, I think we can say confidently that his advice today will be extremely helpful for everyone in attendance. Scott actually picked out this topic today to host a webinar on because it is one of the most overlooked programs, and he has witnessed personally companies not having programs in place. With that, let's briefly discuss what points we'll be talking about today. Also, we will pose some questions throughout the presentation to test your knowledge on respiratory protection. So to get us started, Scott, can you explain to us why respiratory hazard prevention is so important and what we'll be going over today?
Well, respiratory protection is just a part of an overall safety program, but failing to provide a safe work environment can be costly in more ways than just dollars and cents. First, obviously, there could be a potential loss of life, and that would be tragic. Second, a lot of workplace injuries and illnesses are life-changing, which result in restrictions to many lifestyles and restrictions to what injured workers can do in the future. Finally, there's the cost of the investigation, any corrective actions that have to be paid for, regulatory fines, as well as major liability lawsuits that can completely drain a company both financially as well as in terms of staff. It's really important to develop and maintain an effective respiratory protection program so that employers can prevent employees from both short-term and long-term illnesses due to exposure to harmful atmospheric hazards.
I agree, Scott. It is so important for companies to be proactive rather than reactive. This really makes a tremendous difference in a company's safety program. So next we've got our objectives. So just what can our attendees today take away from this webinar?
Well, the objectives of the webinar are listed on this slide. First, we want to make sure that we can recognize the respiratory hazards that employees might be exposed to. We want to make sure that we comprehend the requirements that are set forth by OSHA. So we want to make sure that we know, the OSHA standards relating to respiratory protection and how they apply to your workplace. We want to review the components of an effective respiratory protection program. Make sure we understand the benefits of engineering and administrative controls, improve our knowledge on respirators, know what most respiratory programs are missing, and then also understand why certain respiratory programs fail.
So how do companies identify the respiratory hazards, and is this something they can do on their own, or do they need to hire professionals to come in to do it for them?
It can be a combination of both, but a lot of hazard identification has to be done initially by the company itself. Professionals can give guidance to identifying respiratory or various hazards in the workplace, but in general, the company knows the workplace, so company professionals or company employees have to participate in this. Under the OSHA Personal Protective Equipment Standard, all companies have to assess the workplace to determine if hazards are present or are likely to be present. This hazard assessment allows employers to identify sources of hazards to workers and co-workers, including sources of impacts, penetrations, rollovers or compressions, chemical exposures, excessive heat or cold, harmful dust and mists, unsafe light radiation, and hazards specific to your workplace. From a respiratory standpoint, air contaminants can exist as particulates, fumes, smokes, gases, vapors, mists, or droplets. Examples generating the emissions would include the following: dusts. Next slide, thank you. Dusts, from cutting, grinding, or mixing, or maybe other disturbances of dry materials. Metal fumes from welding, grinding, smelting operations, that type of thing. Solvent vapors that may result from coating operations, applications of adhesives, painting, or use of solvents. Various types of gases from industrial processes. Infectious agents that might cause medical workers to be exposed, and oxygen deficient atmospheres, which might be caused by things like bacterial action, oxidation, displacement of other gases. A lot of times the oxygen deficient atmospheres are found in confined spaces. Yeah, an independent consultant or a safety professional can help identify and evaluate these workplace hazards.
So Scott, can you give us a step-by-step guide on how to properly assess these workplace hazards? I know OSHA's website has a ton of great resources, but everyone, it can also be hard to find what you're looking for sometimes. Do you have any advice there?
Well, to determine the appropriate type and level of respiratory protection, employees have to conduct what's called an exposure assessment. Now, the purpose of this is to identify the levels of employee exposure to air contaminants so that we can select the proper respiratory protection procedures or equipment that we need to protect employees. It's really important that employers make sure they have a good understanding of the various atmospheres in which their employees would be working. So the first thing we want to do is check the OSHA standards. We want to make sure that we identify what OSHA's permissible exposure limits, or PELs, are for the various types of contaminants that are going to be present in the workplace. Next, we want to make sure that we use safety data sheets and product and process information to determine what contaminants might be present. We can also talk to vendors and other users and check with your trade association for information as well. Finally, we want to make sure that we perform air monitoring.
So can anyone conduct air monitoring? And can you tell me why it is so important?
Well, source testing or monitoring of exposures are the key to identifying a company's need for respiratory protection. You really can't quantify anything, and you can't quantify how much employees are being exposed to without doing any testing or monitoring. Data obtained from the sampling will indicate whether or not OSHA requires your company to have a formal respiratory protection program or apply certain engineering or administrative controls. The information is also important when selecting respirators. A lot of gases in toxic environments can have colorless and odorless traits and are unable to be detected without the proper instrumentation and test equipment. This is important because even small amounts of certain extremely hazardous substances can be fatal. Quantifying the amount of contamination in the air is necessary in order to select the correct controls and PPE for the particular atmospheric hazards present.
So this next slide is kind of scary to think about. When you think about if we're breathing hazardous air or not, depending on what type of work environment you work in, either general industry or construction, you could be facing some pretty serious respiratory hazards.
Examples of hazards in the workplace are shown on this slide. Hazards applicable to general industry could include contaminants from process emissions, hazardous dusts or fibers, such as asbestos or maybe lead dusts that are generated during construction in your facility, fumes that are coming from welding, such as hexavalent chromium, and also any other types of hazardous dusts, mists, droplets, or fumes that might apply to your process. In construction, you have to deal with dust containing silica, lead, or asbestos, and various types of fumes that might come from coatings or application of adhesives. Also, we want to make sure that confined spaces are addressed as well. And confined spaces are one of our biggest sources of hazardous atmospheres and employee exposure to those. There are three types of atmospheric hazards that have to be tested for when dealing with a confined space. Those would be oxygen content, a combustible or an explosive atmosphere, or a toxic atmosphere, based on really what was in that space previously or what is being stored in that space currently. Testing needs to include both initial monitoring and then ongoing checks when you're in a confined space.
So would you say that air monitoring is one of the most important steps companies can take to prevent respiratory hazards?
Well, different studies into long-term illnesses and deaths caused by oxygen deficiency and exposure to toxic gases and dust revealed that companies failed to first maybe even identify the hazards before they went into these deadly or these hazardous environments. They failed to install safety systems and thought that maybe employees could work in these environments without particular safety protections. They failed to use personal protective equipment, and they failed to follow the proper safety procedures in the workplace, especially in confined spaces. As far as how to determine what the hazards are, today we have fixed and portable atmospheric monitoring instruments that provide a good way of identifying and quantifying the exposure to atmospheric hazards. They're highly reliable, relatively easy to install and operate. They offer simple maintenance and provide an excellent method to assess respiratory hazards in the workplace.
So all that being said, what are some of the individual methods that can be used to collect air samples, and how does OSHA identify the respiratory hazards during an inspection?
Well, there are a number of ways of collecting samples, and you have to select the way that is going to be best for the work that's being done and the process that you're monitoring in. But some of the examples are shown up here on this slide. Diffusion detector tubes determine a time-weighted average, which is usually an 8-hour average exposure, or a short-term exposure limit, abbreviated STEL, and that's usually a 15-minute exposure. There are also vapor badges, which can be worn in a worker's direct breathing zone, and they also determine the time-weighted average and the short-term exposure limits. Personnel air sampling pumps, which provide more accurate results, but they could be a little bit more cumbersome to use. Handheld gas monitors. And finally, there's fixed air monitors as well that can be installed to continuously monitor your work areas.
So, I do see that respirators are not the only means of controlling respiratory hazards. So can you just explain to me what are some of the other ways to control these hazards, and, what would you say are the most effective?
Well, once we've determined the atmospheric hazards, or that atmospheric hazards are present in the area where people are going to be working, we have to figure out what we're going to do to protect employees. It should be noted that respirators aren't the only means of protecting employees from hazardous atmospheres. Respirators, along with personal protective equipment, are supposed to be actually the last line of defense. Elimination or reduction of atmospheric hazards can be achieved using two other methods. Those would be engineering controls and administrative controls. In fact, OSHA requires that employers must first use engineering or administrative controls to bring employee exposure to airborne contaminants into levels that are permitted under OSHA's various standards for air contaminants. Personal protective equipment may be used to supplement these engineering and administrative controls only when the controls can't feasibly be implemented, or that they can't feasibly reduce employee exposure to below the permissible exposure limits. Engineering controls. I do have a slide here that shows some examples of engineering controls. They're usually physical or mechanical methods used to control hazards. It's usually an engineering control is usually something that you can buy or fabricate and install and take care of the hazard. Examples that we have listed up here show vacuum systems, machine guarding and ventilation, adequate airflow, For airborne contaminants, engineering controls would be process enclosures to, again, prevent the airborne contaminants from spreading. Various types of ventilation systems, which could be as sophisticated as a fume hood over a process line, which extracts various gases or vapors coming off the process into a pollution control device, which eventually discharges outside, or it could be as simple as just using a fan in the area where you're working. Dust collectors are also another example of an engineering control. Blowers, fume extractors, and as I mentioned before, even a simple floor fan can be an adequate engineering control in certain circumstances. Administrative controls are methods used to control the job process itself. Examples of administrative controls would be things like written work procedures. If an employee follows the procedure and stays within that procedure, they're not going to be exposed to the hazard. However, if they defer from that procedure or they stray from that procedure, there's potential exposure to the hazard. Rotation of workers is another example. Rather than having one person work in a hazardous environment for a long period of time, if you could rotate 2 or 3 in several times over a shift, you're not going to have people being exposed long enough to have any health hazards related to exposure. Time management, training, and signage are all other examples of administrative controls.
So this next slide is definitely worthy of taking down a few notes on. Knowing when employees need to wear respirators is frequently overlooked. This is one of the main reasons why you wanted to host this topic today, right, Scott?
Yeah, that's right. In fact, OSHA requires the use of respirators in the following circumstances, and they're basically listed on the slide. Number one, when exposure levels exceed the PEL. So obviously you don't want anyone going into a hazardous environment without some sort of respiratory protection. They're also required during installation and engineering or work practice controls, for maintenance and repair activities that might result in exceeding the permissible exposure limit, for emergency response, where the type and concentration of the contaminant might not be known, and also respirators can be used voluntarily when employees want extra comfort or protection, just to have a little bit more peace of mind.
So obviously, if any business has any respiratory hazards, they need to comply with OSHA's standards and requirements. But more than that, why is a respiratory program so important?
Well, OSHA compliance is important, but obviously the most important thing for any safety program is to make sure that people don't get sick or don't get hurt on the job. And exposure to harmful contaminants such as fumes, vapors, or dust can cause a lot of adverse health effects. Certain effects might be short-term or what we call an acute exposure after a short-term or an acute exposure, or others might surface only after long exposures over a long period of time, which we call chronic exposures. Some can even be fatal. Examples of hazards or health effects that employees might encounter could be cancer, lung impairment, such as silicosis or asbestosis, chronic bronchitis, or even liver damage. It's important to make sure that all individuals who are exposed to harmful air toxins take the appropriate steps to protect themselves. When respirators have to be used, OSHA requires employers to have a formal respiratory protection program. It should be noted, though, that a formal program is not required when respirators are used voluntarily.
So I think the most common question we'll have from everyone attending today is, where do I start to create an effective respiratory program? What's some of the things that are most important?
Well, for a respiratory program, it's really important to have some guidance to follow. Respiratory protection starts and ends with the written program. A written program is required by OSHA if employees have potential for being exposed over permissible exposure limits, and it's the core component to an effective and complete respiratory protection program. The purpose of the written program is essentially to prevent employees from being exposed to contaminated air by implementing safe work practices and procedures and controls. A program administrator has to be appointed. That program administrator has to have knowledge on respiratory protection and has to be designated by the company to oversee the program. Their main responsibility is managing the program and making sure it's up to date with the OSHA requirements.
So this is just another slide to take some important notes on. Here are some of the elements of a respiratory program.
Yeah, the elements of a program, there's 8 areas of concern that have to be addressed in a respiratory program. Number 1, you need to have written work procedures. Those procedures do have to be specific to your workplace. You have to include your air monitoring data and your basis for the respiratory program. You have to have procedures for properly selecting respirators and any other related equipment. Another component is medical evaluations, fit testing, inspection, cleaning, and maintenance of respirators, training, and program evaluation.
So if we do know that we need to use a respirator, let's say, how do we actually pick one out of the hundreds of options that are available out there?
Well, basically when we're selecting a respirator, first of all, we have to know what the respirator is going to be used for. We have to evaluate the results of our exposure assessment. Number 1, we want to compare the results of our monitoring with the PELs, or the permissible exposure limits set by OSHA. If the results show concentrations are higher than the PEL, then respiratory protection is going to be required. We can also look at other occupational exposure limits that are not set by OSHA, but are set by other alternative agencies, such as the National Institute for Occupational Safety and Health, that's abbreviated as NIOSH, N-I-O-S-H, or the American Conference of Governmental Industrial Hygienists. Both of these agencies have their own exposure limits, and sometimes, actually many times, they're lower than what the OSHA PEL is. So if you're looking for extra protection, you may want to be looking at these exposure limits. Any respirator that's used has to be approved by NIOSH. All NIOSH approved respirators have what's called an APF, that stands for Assigned Protection Factor, and they range from 5 to 10,000. Now, what an assigned protection factor is a workplace level of respiratory protection that a respirator or a class of respirators is expected to provide if properly worn and if you follow your respiratory program. For example, an APF of 10 means that when selected and used correctly, a particular class of respirator can reduce exposure limits that are up to 10 times the PEL. Or you can look at it in reverse, where an APF of 10, where you have an APF of 10, that would mean 1/10 of the airborne contaminants filtered by the respirator still may possibly be inhaled. An APF of 50, for example, would mean 1/50th of the airborne contaminants could still possibly get through the respirator. As far as selecting the right respirator, number 1, you want to make sure that you determine the properties of the contaminant that's present. So you want to certainly obviously know what the contaminant is. Is it chemical or physical? How toxic is it? What is the concentration? If it's an oxygen content issue, what is the amount of oxygen that's available? Then we want to use the assigned protection factors, or the APFs. They can be found in Table 1 of the OSHA Respiratory Standard for General Industry to make sure the respirator will meet or exceed the level of respiratory protection required. We want to consider the type of work that's being done, and we want to make sure that we choose a respirator that's not going to significantly affect the employee's performance. Again, we want to make sure that the respirator also is approved by NIOSH, the National Institute for Occupational Safety and Health.
So this next slide is showing us 2 different types of respirators that we can consider in the workplace. Can you tell us about them and what are the benefits to choosing each one would be?
Well, as mentioned, there's 2 types of respirators, tight fitting and loose fitting. Tight fitting forms a complete seal with the face, and loose fitting does not perform a seal with the face. Again, employers have to select the respirators depending on the type of work that's being done and how it's going to affect the performance of that work.
So that covers the types, but once employers determine the type of respirator to be used, the next step is to decide on the class. So what is a class of respirator and why are there different categories?
Well, there are two classes of respirators, Rick. Air purifying respirators, abbreviated as APR, and supplied air respirators, which are abbreviated as SAR. Air purifying respirators use ambient air, so it uses the existing air and it cleans contaminants from that existing air by using filters or cartridges. Examples of an APR would include a dust mask, half and full face piece, tight fitting respirators, and powered air purifying respirators. Supplied air respirators provide users with a source of clean air from a compressor or a tank. Examples there would include airline respirators, self-contained breathing apparatuses, they're abbreviated as SCBA, and emergency or rescue respirators. Let's just talk about air purifying respirators first, and I'll talk a little bit more about them. Air purifying respirators, as I mentioned before, use the ambient air and they clean the contaminants from that air by using filters or cartridges. There's three types that you can choose from. A particulate, a respirator that filters gases and vapors, or a combination, which deals with both particulates and gases and vapors. When it comes to supplied air respirators, we have three types that we want to look at. Airline respirators have an airline hose which provides clean, breathable air from an uncontaminated source. A lot of times it's a compressor or a fresh air generator. With an airline respirator, this provides you a capability to work for an extended period of time. You also have a combination respirator, which is listed second here. They're usually more of a rescue type respirator. It's an auxiliary self-contained air supply used in emergencies or if the primary air supply fails. They're sometimes used also when entering or leaving hazardous atmospheres like a confined space. Finally, the third type is the SCBA, stands for self-contained breathing apparatus, which consists of a clean air supply in a tank or in a pack of some kind. A closed circuit type can provide air for up to 4 hours, and an open circuit can provide air for 30 to 75 minutes.
So when it comes to hazardous atmospheres, I keep hearing this term IDLH thrown around. What exactly does it mean, and can you provide some examples?
IDLH stands for immediately dangerous to life and health. And there are three main times where you want to basically assign an atmosphere or an area as IDLH. Number one, all oxygen deficient atmospheres are considered to be IDLH. Second, any atmosphere where monitoring shows contaminant concentrations to be extremely high sometimes need to be treated as IDLH. Basically, a lot of times you can look on the safety data sheet for the type of contaminant that you're dealing with, and it will many times identify what an IDLH atmosphere is and what the concentration for that atmosphere would be considered to be an IDLH atmosphere. Also, any atmosphere where we don't really know what the hazards are or what the hazardous exposure levels are going to be also has to be treated as an IDLH atmosphere. When defining an IDLH atmosphere, we have to make sure that we either use a full face piece SCBA, self-contained breathing apparatus with a minimum service life of 30 minutes, or a full face piece supplied air respirator with auxiliary self-contained air supply.
And this brings us to our first question. Yes or no, do you need to be medically cleared to wear a tight-fitting half-mask respirator, only if you're voluntarily wearing it? Got some good answers coming in here. The answer to that is yes. Even if you are voluntarily wearing a tight-fitting respirator, you do need to still be medically cleared to wear it. So this previous question leads us into the next component of the respiratory program, which is medical clearance. So a little bit more in depth, Scott, can you tell me what it is and who exactly needs it?
Well, medical evaluations have to be completed initially before any employee is permitted to use a respirator. Now, there is an exception there, and that is when employees use a dust mask on a voluntary basis. If a dust mask is required to be used by the employer or by the situation, then medical clearance is required. Also, all tight-fitting respirators have to be medically clear, or employees have to be medically cleared to wear all tight-fitting respirators, whether it's voluntary or required of the employee. A medical evaluation is initiated when an employee first completes a form that's provided in the OSHA respiratory standard to identify any medical signs or symptoms that are related to their ability to use a respirator, such as a heart condition, lung disease, claustrophobia, or COPD, anything like that. A physician or licensed healthcare professional then has to review that information and determine whether or not the employee is medically fit to wear the respirator. This may or may not involve a physical examination. A lot of times a physical examination is not needed. Medical clearance is usually a one-time thing. So, once an employee gets their medical clearance, you usually don't have to do it again. However, reevaluation by a physician or licensed healthcare professional is required if you have one or more of the following circumstances. Number one, the employee reports medical signs or symptoms that are related to their ability to use a respirator, again, such as maybe a heart condition, lung disease, or claustrophobia. Or number two, a physician or licensed healthcare professional, or the employee's supervisor, or the respirator program administrator informs the employer they need to be reevaluated.
So this brings us to our next poll question, which reads, how often does an employee need to receive medical clearance in order to wear a respirator? Is it A, monthly, B, once per year, C, there are no requirements, or D, only under certain circumstances? Got some good answers coming in here. So the answer to that is D, only under certain circumstances, as Scott just reviewed. Even after you've been medically cleared to use a respirator on the job, there will be times when you do have to be reevaluated by a physician or a licensed healthcare professional. As Scott mentioned, that you must be reevaluated when you report any medical signs or symptoms that are related to your ability to use a respirator, such as heart conditions, lung diseases, claustrophobia, etc. Physician or licensed healthcare professional or your supervisor or the respirator program administrator can also inform your employer that you need to be reevaluated. Information from the respiratory program itself, including any observations made during fit testing and the program evaluation, that would indicate that you need to be reevaluated. And finally, if a change occurs in workplace conditions that increases the burden on you while you're using the respirator, for example, if your job becomes more physically demanding, or you must wear any additional protective clothing, working in extreme temperatures, some examples like that. And this brings us to our next question as well. Do respirators need to fit well in order to be effective? It's just simple yes or no. We have some answers coming in. The answer to that is yes.
Yeah, once a respirator class and type have been determined and you've gotten medical clearance for your employees that are going to be wearing your respirators, employers next have to make sure that respirators fit properly. Now that's accomplished by fit testing.
So Scott, what is fit testing exactly? And can anyone perform a fit test even if they just look up how to do it on, say, YouTube or another instructional site?
Fit testing is an assessment of the seal between the respirator Fit testing is an assessment of the seal between the respirator and the employee. Okay. Fit test protocol requires employers to perform a series of exercises such as shaking their head, yes or no, looking up and down, deep breathing, normal breathing, etc. And while they're doing that test, there's a number of there's some measurements that are being taken place or observations that are being taken place by the person that's giving the test. The tests take about 15 to 20 minutes, and they can really be conducted by anyone as long as they have the proper equipment. There's two types of fit tests. The first fit test type is qualitative fit testing. Now, a qualitative fit test is a pass-fail test that relies on an individual's response to a test agent that's introduced to the area where the employee is wearing the respirator to detect whether or not that respirator is leaking. Usually you would do a qualitative fit test for a half mask or full face air purifying respirators, but sometimes you can also use them for dust masks. Test agents that would be accepted by OSHA would include isoamyl acetate, which smells like bananas, saccharin, which gives off a sweet taste in the mouth if it leaks through the respirator, Bitrex gives off a bitter taste in the mouth, or irritant smoke, which causes coughing if employees are exposed and the respirator leaks. Quantitative fit testing is the second type of fit testing. Now, quantitative fit testing is an assessment of the adequacy of the respirator fit by numerically measuring the amount of leakage of a test agent introduced into the respirator itself. Quantitative fit tests can be used for any type of tight-fitting respirator. Test agents that you would use in quantitative fit testing would include generated aerosols, ambient aerosols, and controlled negative pressure.
And this brings us into our next question. If an employee refuses to shave because of religious beliefs, what is the best way to handle this situation? Is it A, explain that OSHA has no specific exemption from citations for employers whose workers, for religious reasons object to wearing respirators in the workplace? B, take into account that certain circumstances do still require tight-fitting respirators? C, you want to consider other respiratory options such as power air purifying respirators or PAPRs, in those situations where they still would provide adequate protection. D, you would speak to the individual with politeness, courtesy, utmost respect when discussing their religious beliefs. Or D, you want to take all of the above into account. Have some more answers coming in. The answer to this one is E, all the above. You definitely want to take all these into account when dealing with an employee that can't shave because of a religious belief and they have to wear a respirator. So the next slide covers training, which is definitely one of Lancaster Safety's specialties. Something I know all of our trainers stress over and over again is documentation. All the training you encounter and go through needs to be documented in some form. So Scott, can you tell me what exactly does the training need to include?
Well, again, as mentioned, training needs to be conducted prior to employees using respirators and before they enter a hazardous atmosphere. Training has to include, number one, the hazards and risks of not wearing a respirator correctly. Second, how to inspect, don and doff, which means put on and take off the respirator. How to perform a seal check and use the respirator. Also, when covering respirator use, you also want to talk to them about what not to do, the improper use of a respirator, and some of the problems created there. Also, you want to talk about how to perform maintenance and properly store the respirators, how to react in an emergency situation or the failure of the respirator, and how to recognize medical symptoms or issues that could cause the respirator to become ineffective.
So with that being said, how does an employee make sure that they are getting the best possible respiratory protection?
Well, whoever's going to be using a tight-fitting respirator, or again, sometimes a dust mask as well, that person needs to perform what's called a seal check. And a seal check's not to be confused with a fit test, because a fit test is a much more comprehensive procedure. But OSHA requires that both a positive pressure and a negative pressure seal check be done every time an employee puts on a respirator. The positive pressure seal check is where the wearer closes off the exhalation valve, that's usually on the under the chin, and gently exhales into the face piece. The face piece is considered satisfactory. The fit of the face piece is considered satisfactory if a slight positive pressure can be maintained inside the face piece without any evidence of outward leakage. The second fit test you provide, or seal check you provide, is a negative pressure seal check. Negative pressure seal checks where the wearer closes off the inlet openings to the cartridges by covering them with the palm of the hands or by inserting filter seals. Then the employee inhales gently so that the face piece collapses slightly. The worker is supposed to hold their breath for 10 seconds, and if that vacuum holds, a proper seal has been achieved and the worker can enter a hazardous atmosphere.
So we've gone over some aspects of a successful respiratory program, but one thing we'd like to cover here as well is where most respiratory programs are failing. So can you give us your insight, Scott, onto some of the common areas where they are failing?
Yeah, well, the first place where respiratory programs fail or where employers fail in protecting employees from respiratory hazards is that a lot of times employees won't wear respirators. Okay, respirators have to be comfortable or they're not going to be used. They have to fit well or they won't be effective. So you need to make sure of comfort and proper fit. To have a good respirator program, you need to consider all kinds of things, not just about wearing the respirator. Common component that's missing from a lot of companies' respiratory programs is the medical evaluation. We talked about that. Nearly half the companies that require respirator use have not had proper medical assessments to determine an employee's fitness to wear a respirator. Also, annual fit testing and training also appear to be failing as well. They appear to be far from a universal practice as required by OSHA, so they're sort of all over the map.
So we're kind of winding down here to the end of the webinar. We just want to make sure that everyone understands all the important aspects of a respiratory program. So I know I learned a lot today from Scott and hope you all did too. And he's going to go over some of the main points and we hope you can take away from today.
So our main takeaway points from the webinar today include, number one, air monitoring is going to give you that better overall understanding of the hazardous atmosphere in which employees are going to be working. Very important to conduct air monitoring. Second, there are 3 ways of addressing safety hazards and health hazards. We don't have to just rely on personal protective equipment. But engineering controls, administrative controls, and PPE all can be used to protect employees from respiratory hazards. Third, we want to make sure that employees use the correct type of respirator for the task. For instance, when entering IDLH atmospheres, you can't use an air-purifying respirator. You do need to make sure that you're wearing a supplied air respirator of some type. Next, we want to make sure that proper medical clearances and fit tests are conducted when required. And finally, we want to make sure adequate respiratory practices are used, because that is the key to a successful program.
We just want to thank you all for taking the time to listen in today. If you do have any further questions, please call Lancaster Safety at 403-6026, and we'll definitely be more than happy to help you. Also, if you could follow us on social media for any more news updates, safety information. You're more than welcome to provide us feedback as well on Yelp, Google, and Facebook. We do truly appreciate your time. Hope you will take advantage of our monthly safety and health webinars. Everyone is always invited to attend, and they're always free. Just visit our website and click the link on your screen for more information, and have a safe day.
Thank you.